Alright, welcome back to my YouTube channel again. Today we are going to talk about constructing a predictive parsing table. Alright, so before we get to actually constructing the parsing table, we need to get rid of some few pesky, disturbing things. Number one, we need to talk about the first and follow function. The first and the follow function. What are the first and the follow functions? The first and follow functions are functions that actually help us to choose which production to apply. Like, since this is a top-down parser, we are going to have to derive, not reduce. And since we are deriving, because of the possibility of a production having multiple alternatives, we need to use a special method of finding out what to pick at each of the individual times where we are actually deriving. And that's where the first and the follow functions come in. Now, I will talk about what the first and follow functions are, but then we have to note that the follow function is what becomes the basis for synchronizing tokens, which show up in our panic mode error recovery method in when we are dealing with parsers generally. Because of how the follow function works, we can use it as the synchronizing tokens. So now, without further ado, let's get to the first function. The first function. So what is the first function? The first function of a grammar symbol. Let me just of a string of grammar symbols, alpha, where alpha is the a string of grammar symbols, not just grammar symbol. One grammar symbol just means one unit of, but a string of grammar symbols. That's what this alpha here is representing, and we can say that the first of the grammar symbol alpha is a set of terminals that begin begin strings, not a string, begin string derived from alpha. Okay, so look at that. A set of terminals that begin strings derived from alpha. We can have, let's say we have alpha. In this case, could be let's say x derives x a b c. Let's just say a b c in this case, because x is a non-terminal, and the non-terminal cannot be the first, because it has to be a set of terminals. So a is the first of x here, a, because it's one coming first. We're going to get to how to know which is how to compute the first of something. I'm going to get to know how to do that, but just note that this is what it is. And then if alpha in 0 or more steps derive empty, then we can say empty is also a first in that case. So that's about the first function. So let's get to the follow function. And the first was talking about a grammar symbol. And please know your conventions. So big A here is definitely a non-terminal. It's not a grammar symbol. A is a non-terminal, and we know why we are using it as that. So what is the follow of A? The follow of A, which is a non-terminal, is a set of terminals. So we realize that the first and the follow functions are set of terminals. Like, they are set of terminals that can, in this case, that can appear immediately to the right of A in some sentential form. So in this case, we know we are not just talking. When I mention sentential form now, I'm not just talking about the sentence, which is just id plus id star id, which are all terminals. In a sentential form, we can definitely have non-terminals and terminals. So we are trying to say that if let's say a derives a, then a, then b, then a, the follow of a, this big A in this case, is going to be small a, because it's coming immediately to the right after A. in this sentential form. So now, if A can also be the rightmost symbol in a sentential form, rightmost symbol in a sentential form, then the dollar sign is in the follow of A. Okay, having said that, let's now get into the computation of the first and the follow set. So I'm going to start with the first. So how do we compute the first set? So now, number one, these are the rules that influence the first and follow set, how we use them. So let's say X is a terminal, because X can be a grammar symbol. X in this case is not a string of grammar symbols. X, Y, Z, they are grammar symbols, just one grammar symbol. So if X is a terminal in this case, then the first of X is X. Note that this is just because, okay, we are dealing with a terminal, so there's no production here, and it is a terminal itself. So the first of X in this case is itself, because it's a terminal, and then the first of the function is a set of terminals that begin the string. So X begins itself because it's a terminal, and then because of that, it is in the first of X. So that is number one of the three rules that make up this. So the second rule is, if X is a non-terminal, then X now has some productions y1, y2 to yk. A will be placed in, I'm just saying an arbitrary A now, A will be placed in the first of X if in these entire productions and everything now we don't find any non-terminal, or all of them are deriving empty except for one of them. If one of them, let's say yi, has A as the first of it, as A as the first terminal in that production, and then let's say the rest of them, y1, y2 to yk minus 1 or anything, or let's say just yk minus 1, if all of them have empty, empty, so all of those will be ignored. All of those will be ignored until it reaches yk, which, if yk now has A, then A will now be placed into the first of X. I'm going to use an example to demonstrate, so you do not have to worry. Okay, so moving on to 3. If X derives empty, then add empty to the first of X. So I'm going to just create a new layer here, and then let's talk about the follow. I'm going to come back to that, because when we are actually computing the sets, I need to point out some rules for you guys to see and how they work. That is very, very important. So I'm not going to clear everything, I'm just going to hide it. Now, how do we compute the follow set? Okay, so number one, the dollar sign is in the follow of S, where S is what is the start symbol. Then, and the dollar sign is not the stack's bottom marker, it's the right end marker of the input buffer. Right end marker of the input buffer. This is going to be very, very important down the line, but just note that The dollar sign is in the follow of S if S is the start symbol naturally by itself. That's rule number one. Rule number two is that if A derives, watch with me, alpha, B, beta. Let's break down this. Let's analyze this. What does alpha mean? Possibly empty string of grammar symbol. So it can be empty, it can be a terminal, and it can be a non-terminal. Note that. The same goes for beta. I used an entire video to talk about the importance of notations because of this. It was at this point in time manipulations get crazy, and if you do not know what a symbol means, yeah, you won't be able to answer the questions. And if you like, just go and hack ChatGPT. Okay, so now we have this. What then do we say? Then the first of beta except E, which is empty in this case, is in the follow of B. Let's go over that again. A derives alpha, B, beta, where the B here is a non-terminal. Then the first of beta is, except of empty, is in the follow of B. So if beta is, say, a string of small terminals, then the first of that is going to be in B. In B. Now, in the case where the beta is a terminal itself, then that terminal itself is going to be in the follow of B. I'm going to use an example to make all of this clear. So, what is the third rule? We've established that. Now, if A derives alpha and beta, no, alpha and B here, big B. If A derives alpha and big B, or A derives alpha, B, and beta, where the first of beta, let me create more room, where the first of beta contains, let's just write that out, contains an empty. So in short, we are saying that this guy contains an empty, the first of beta contains an empty. What do we do? Then everything in the follow of A is in the follow of B, is in the follow of B. Let me go through the let me dissect it for you to notice again. What did I say about alpha? Alpha can be a possibly empty string of grammar symbols. It means it can be A, it might be B, it could be empty. And empty in code there is very, very important because some manipulations will require us to treat some things like they don't exist and come to a conclusion, right? So remember, possibly empty string of grammar symbols. And then B. This is the first equation, let me call it that. And now the second equation says what? If A derives alpha, possibly empty string of grammar symbols, big B, and beta, which is also a possibly empty string of grammar symbols, and then the first of beta, contains E, which is empty. What then do we say? Everything in the follow of A. So let's say A already has its own follow, like we have already computed some follow for A. Then we can just take all those follows and put it inside the follow of B. Weird, right? But we are going to use an example to clear every doubt. So I'm just going to hide this so that we can get back to it later on. Now, let's use an example. I'm just going to compute the first and I'll compute the follow shortly after. And then after that, we are going to draw out how the table would look. So, example. We have a non-left recursive grammar. We have already pruned it. We've treated its mess up. We have this. We have e prime derives. Is that plus? Yeah, plus t e prime or mt, or t derives f t prime, or t prime derives star f t prime or mt. Then f derives uh, e in parentheses and id. So we have this written out. Let me scale that down so I can have more room for the table. So let's talk about how the computing the first and follow function, because we need that for constructing the parsing table. So we have first here, we have the follow here, and then we have the non-terminals. So what are the non-terminals? We have e, we have e prime, we have t prime, and we have f. Okay, so what did I say about the first? Let's hide this and show. So this is the grammar. This is what we have. We have e derives t prime and everything. Look at what I did here. So going to this, we talked about the first. We said if x is a terminal, then the first of x is x. Now we also said if x is a non-terminal, then x derives y1, y2 up to yk, and then a is in a is going to be in the first of x if yk has an a as the first terminal in the production. So let's go back to what we have here. So look at this. We are starting with e as the first function, this big E here. So e derives te, but then t here derives what? T derives e, f. Now let's say t derived f, that f derived nothing or f derived empty. We are going to have to shift to another the non-terminal. But then t derives f, and f derives the first terminal here is the open parenthesis, and that is going to make the first of e, because e derived this guy, and this guy derived this guy, and this guy derives this. So we have landed on a terminal. So we steal that terminal and we use that as the first of e. So we have this guy. All right. So what then do we have again? Now notice that when we landed on f and f derived the open parenthesis, we also notice that there's another alternate production for f, which is id. So we can simply have both of these guys, since they are both productions of f, and then e derives both of these productions eventually. We can steal those two and make that the first of e. So the first of e here is the open parenthesis and the id. So we have gotten to the end of that. Now let's look at e prime, since we're on the next guy now. E prime derives plus t e prime or empty. So the first production here, we already noticed a terminal, and thank God for that. So we have a plus as one of the firsts, and then empty also is derived by e prime. So what do we have as the first? We are going to have plus and e prime. Note again, because e prime, this slash here is just an alternate. It's still just saying e prime derives e. That's just what this is saying. It's just that we are short forming it. So it's a shorthand method. So the first of e prime is plus and empty. So let's go on to t. So t derives f, and f derives open parenthesis this guy and id. So we are going to just steal that and use that as the first of t as well. So id and open parenthesis becomes the first of t. Now moving on to t prime. The first of t prime, we already see a star, which is a terminal, and then empty. So we just steal those two and we use that. So we have star and empty. Now finally we have f. So f, which was the primary one where we stole all our first from in many cases, we have the open parenthesis and id. So we are going to pack that as the first of f. So we have open parenthesis and id, and thus we have computed the first of all of these guys. And you can pat yourself in the back. Let's see the closing prayer and let's be on our way. Wrong, wrong. We still have the follow function to deal with. Now, how do we do for the follow function? Remember the law. I'm just going to open the follow function. First things first, the dollar sign is in the follow of s if s is the start symbol, and dollar sign itself is the right hand marker of the input buffer. So what are we trying to say here? Going back to our table, e is the start symbol, not s in this case. E is the start symbol. So what do? We add dollar sign automatically to the follow of e. Now watch with me. E derives te prime, right? But then we are saying that in a sentential form, since we are dealing with the follow now, in a sentential form, if whatever terminal is following e is going to be in the follow of e prime. So now let's look for e everywhere here. E derives t prime and te prime. No, e derives, this is e prime. So we are looking through the sentential forms for e, and then we find e in f. What is the terminal that follows after e directly? We have the closing parenthesis. So we are going to steal this and we'll make that our follow of e, because it is directly following it. It's immediately to the right of e. So we are going to take that, and then we are going to use that also as our follow. So thus we have computed for e, but there might be others. We don't know. So let's just look at it. Now, moving on to e. I'm going to copy one of the laws for you again. So now let's say we have this guy over here. I'm going to steal this guy. I'm going to bring it in so you can see. So we have a derives dollar this and this. Now let's go back. So remember what I said? I said a derives alpha and b, and then what is in the follow of a is going to be in the follow of b. Now let's look through e prime, right? But let's look at e derives t e prime. Now let's say t is alpha and this e prime is b, because that's what we are trying to get the follow of. You can say that the follow of a is in the follow of b. So the follow of e, whatever is in the follow of e, is going to be in the follow of e prime automatically. So we steal that and we put it there. So we have the close parenthesis and the dollar sign. So the close parenthesis and the dollar sign is going to be in the follow of e prime. You can watch it again if you missed that. Now we move on to t. So now what do we have? We have t here. We have t. I'll go back again to the rules so that you can see. T derives f t prime, and then in somewhere we have e prime derives plus t e prime. Now I want you to look at this with me. Going back to the rules, what do we say? We said if a derives alpha, b, and beta, we can say the first of beta, which is this guy here, is going to be in the follow of b. How do we apply that in our current situation? We are trying to get the follow of this of t, right? We are trying to get the follow of t. But then since t already exists in some other productions, we are going to have to apply that law. So we have alpha, big B, and we have beta. So treating plus as alpha and treating e prime as beta, what do we say? We say the first of e prime is going to be in the follow of t. So what is in the first of e prime? We have plus. So let's just hold on for that. We have plus there. All right. So what else again can we do to add to this our current guy over here? So we also talked about we have f t derives f t prime, All right, and we can say that what is in the before we get to that, let's move on to t prime. Let's move on to t prime. We are going to be filling these entries as they come. So what do we have in t prime? We have t prime derives star f t prime, and then what do we look at here? Using the same symbol, we have the same principle. We have alpha, big B, and beta, and we can say what is in the follow of t prime. What is in the first of t prime is in the follow of f. So here we can easily just compute that since star is in the first of t prime, we can just simply put that in the follow of f. So we'll do the star. We are just filling this. We are filling this as we notice, because you have to scan through, see what works, fill that in, scan through again, see what works, fill that in until we have every possible entry filled out. So for t prime, we have t derives f t prime. Now remember that rule, A derives alpha B, and then we can see what is in the follow of t is in the follow of t prime because of that. So what do? We take the follow of t, which has a plus now, and we just put it into t prime. So we have a plus A as well. That is not all. We are not yet done. We are still going to have to deal with, okay, what is in f? What is in f? How does that work? So now going to f, we know that we aren't just going to take f and just use that like that. We are going to have t prime. We are going to check through the sentential forms. We have t prime derives star f t prime. Now remember that same system, alpha, big B, and beta. So let's say we can have the first of t prime is going to be in the follow of f. We have that already. We've done that. Then we can also check again, t derives f prime. That is another sentential form that we can have, f prime, and we can say the first of this is in the follow of first of this is in the follow of that. It is that. And moving on, what else can we do? What else can we do to arrive at that? So looking at E, let's continue seeing if we can fill more entries in the follow of T. Let's go back to this guy. E derives T E prime. All right. So if we draw out this, we can have A derives alpha, alpha, beta, alpha, big B, and beta. Yes, this is where it gets interesting. Take a look with me. I'll write it out again so it will be clear. A derives alpha, big B, and beta. Now let's say this guy is beta, right? And this guy is big B. And now you know there's nothing else here, right? But what does empty also connote? Empty connotes that there's nothing here too. So let's say empty is our alpha here. So look at this. What do we have? We are going to say that the follow of E is going to be in the follow of T. I'll go again. Alpha derives, A derives alpha, big B, and beta, and then whatever is in the and if beta derives empty, let's go back to that so that I'm not blubbering nonsense. Look at this in the third row. We have it here. Let me underline. In the third row, we have A derives alpha, big B, and beta, and if the first of beta contains empty, then the follow of A is in the follow of B. So we go back to this guy. What is beta A? E prime. Beta is E prime. So what is in the first of E prime? The first of E prime contains empty, and because of that, the follow of A, which is E in this case, is also in the follow of T, which is the big B here. So what do? We pack all of these guys, which is the follow of T of E. We pack it up to the follow of T. So this is what we have. Now we have earlier said that the follow of t prime, the follow of t is also in the follow of t prime. But let's just use this again. So we can say A derives alpha and big B, and then whatsoever is in the follow of t is in the follow of t prime. So what do? We go back and take whatever is in the follow of t and put it in t prime. So we have open bracket and then we have dollar sign. Good. So we have something working out. I'm just going to clean this again. I'm going to clean this again, and then we look at what we have in the F, the entry for F. So looking for the sentential form where F resides, we can say T derives Ft prime. Now recall what I did with the previous one where I said A derives alpha, big B, and beta. In this case, MT is going to be the alpha here. So what do we have? We have T derives Ft prime. And now check T prime. Is there MT in the first of T prime? Yes, there's an MT in the first of T prime. So what do we say? We say whatever is in the follow of T is in the follow of F prime. Of F, not F prime, there's no F prime. Whatever is in the follow of T is in the follow of F. So what do? We pack all the follows we've had here, in T, and we put it inside F. So we have plus, we have close parenthesis, and we have dollar sign. And at this point, if we look through, we would not find any more first and follows, and we can then say we have computed the first and the follow of this of all of these things. This is the grammar. This is the grammar. We have constructed all the first and follow sets. That is that. Now I'm going to do the construction of the table, and then we will look at another example in another video. So I'm just going to clean this up, and then okay, so how do we put this into the table? Remember what we did the last time? We talked about the parsing table, and we said the parsing table looks something like this. Parsing table will be M that has, it is in two-dimensional array that has X and A, where A is the input symbol and then X is non-terminals. In this case, X just consists of the non-terminals. So how does the table look like? We are going to have to separate an entry for the non-terminals and then for the input symbols. So I'm going to just draw this out roughly. Now the input symbols consist of, in our case, we have ID, we have plus, we have star, we have the open parenthesis and the closing parenthesis and dollar sign. So I'm just going to draw out those entries like so. Now what are the non-terminals? E prime, T prime, and F. So let me just make them into boxes. So this is the two-dimensional array. We have the non-terminals first, and then we have the input symbols next. So each of these are unique entries. Now if you remember, we had, oh, I've deleted the table, deleted the previous table. I believe that for the first and follows, we have that written down. I'm just going to have to write it again. Dang it. So we have we have E prime, we have T, and then we have T prime and F. So in the first of E, we have dollar sign, we have ID and open parentheses. For the first of E prime, we have plus and we have empty. First of T, we have star and we have empty. First of T prime, we have star. First of T, we have for the first of T, we have open parenthesis and ID. For the first of T prime, we have star and empty, and then first of F, we have open parenthesis and id. Now what about the follow? The follow, as we did earlier, let me just do this and this. So in the follow for e, we have open parenthesis and dollar, close parenthesis and dollar sign. We have close parenthesis and dollar sign for e prime as well. Then for t, we have plus open close parenthesis and dollar sign. And then for t prime, we have plus close parenthesis and dollar sign. And for f, we have star plus close parenthesis and dollar sign. These are important in the computing of the table, and they are very small, but I believe if you were taking notes, you have the entire thing, and you can just reverse the video in case you are looking for that. I'm having this so that I won't be too vague in my explanation. So back to the table, we are going to have to put we have the entries based on the productions of E, productions of E prime, productions of T, productions of T prime, and production of F. So we are going to first of all fill in for the first symbols, for the first set. First fill in the first, and then we'll use the alternate production in the follow, which is usually in the empty. Now, what do we have for the first? We have for the first one, we have open parenthesis and id. So what is the production that we have on E? We have E derives T E prime. So putting that into the first, and then the first contains the open parenthesis and id. So we are going to fill in E derives T E prime, and then for id also E derives T E prime. So we are filling the first with the productions. So moving on to E prime, what do we have? We have plus and we have empty. So we are going to ignore empty because empty is not existing on the input symbol. There's no empty in the input symbol. So empties are not going to show up as strings. We are going to use the empty for something else. But note that plus is among the input symbols, and then we have a plus as the first in E prime. So what do we do? What is the production on E prime? E prime gives plus TE prime. So what do? We fill that in. So E derives plus TE prime. We have that already set. So we move on to T. What is the first of T? We have open parenthesis and ID. So having that, we're going to just fill in the productions wherever those symbols are. And what is the production on T? Production of T is ft prime. So what do? We fill that in the open parenthesis, which is here. So T derives ft prime, and then also at id T derives ft prime. Then moving on to T prime. What is in the first of T prime? Star and empty. We can't use empty like that, so we're going to just focus on star. So what do? We fit in the productions of T prime, which is T prime derives star f T prime or empty, but now realize we are going to use that empty for something else. So in the star place, we are just going to fill in the star entry, we are going to fill in star f T prime. We have dealt with all the firsts of these guys, remaining F. So what is in the first of F? We have the open parenthesis and ID. What is the production in F? We have open and close parenthesis, empty, not empty, E, and then we have ID. So note where we are putting each of these values for in this case. F derives open parenthesis, and then from there we see a pattern matching. There's open parenthesis here. So instead of putting F derive ID in the open parenthesis, we're going to put F derives open parenthesis E close parenthesis. So we have that. Now F derives ID, and then there's an input ID over here. So we are not putting F derives open parenthesis E close parenthesis with ID. We are going to put F derives ID here. So it's more like pattern matching. Observe this. Look at this place where there's a plus and then there's a TE prime. It's on the plus entry. Notice this star FT prime is on the star entry. But then we have dealt with, and then look at f derives id is on the id entry, and then f derives open and close parenthesis e on the open parenthesis entry. Now we have all those sets, but what do we do with the follow? What do we do with this dollar sign and these guys over here? If there was an empty in the productions, like let's say in this case we have e prime also derives empty, e prime derives empty, t prime also derives empty. Recall that there was no empty in the input symbols. There's no empty in this space. We just have all of those terminals. So wherever the follows are is where the empty is going to be, the empty productions. Because if we cannot derive empty, we're not adding empty to the follow of these guys, which is close parenthesis and dollar sign. We're not adding empty here, because come on, there's no empty. It doesn't derive empty, so we are not adding anything. We are just going to leave it blank. And what are these blanks? Error entries. If anything shows up here, if you try and find anything e plus in me plus, it's going to return an error, because such a thing shouldn't exist from our grammar, right? So now, since e does not derive empty, we are going to skip on e, but e prime derives empty, and empty is also in the first of e prime, and is also in the first of t prime. So what do we do? For every instance of the follow, we are just going to put the empty productions. So where are the empties of e prime? It's in the dollar sign and it's in the close parenthesis. So what do? We are going to take e prime. I should have added e prime. E prime derives empty, and also in the dollar sign e prime derives empty. Okay, so what do we do again? T doesn't have an empty production, so we are not going to work on that, but T prime has an empty production. So for the T, we are going to leave these places blank, but for T prime, what are the follows of T prime? Follows of T prime as the follow of T prime as plus closing parenthesis and then the dollar sign. And since T prime has an empty production, we are going to put the empty production in these follows. So in the plus, we are going to put T prime derives empty. In the closing parenthesis, we are going to put T prime derives empty. And in the dollar sign, we are going to put T prime derives empty. Since F does not derive any empty, though they have follows, but since there is no empty production, we are not going to fill in anything to this place. So these parts of the table, they are going to be blank. So I believe we have come to the end of this particular table and we have finished it. In the next video, I'm going to make we are going to deal with another example, a possibly tougher example, and then we are going to generate the table as well. So I'll see you guys in the next video. Thank you for watching. Have a nice day.